Hey everybody. All right, today we're going to walk through the Unit 3 study guide. The answers to all of the problems are located at the end of the document. If I scroll down here, you'll see, all right, that all of the answers are here, okay? I'm going to go ahead and show you how to actually solve the problems. What you should probably do is you could solve along with me if you'd like. I'll pause before each problem or each set of problems. You can do the problems and then restart the video and watch the walkthrough. Or you can do the whole sheet, check your answers, and if there's a part that you missed and you don't know why you missed it and you can't figure out what you did wrong, then you could just go to that portion of the video and watch as I solve that problem, and hopefully that will help you understand what happened. So this unit was all about slope, finding the slope from an equation, finding the slope from a graph, finding the slope from 2 points, finding the slope from or being able to write an equation from a slope and a point. And it was about horizontal lines and vertical lines and parallel lines and perpendicular lines and just everything about slope. So remember that slope basically means the steepness of the line. So if this is your coordinate plane, a line that goes to the right, up and to the right like this, has a positive slope. A line that goes down and to the right like this has a negative slope. A line that is close to being flat has a low number slope. A line that is steep, like that one, has a high number slope. And there are a variety of ways, as I said, to calculate it. So let's take a look at what we've got here. Learning target 1 was to identify the slope of a linear function given the equation of the function. Name the slope of each equation. Now it's important to note that when you're given an equation and you have to identify the slope, your equation must be in slope-intercept form. That is y equals mx plus b, because that is the slope right there. If your equation is in standard form, ax plus by equals c, then you see you don't have slope. You have a, b, c, but you don't have m. So it's really important that you change any standard form equations into slope-intercept form before you try to identify the slope. And as I said, if your equation is in slope-intercept form, then it's really easy to find the slope because it's the coefficient of the x value. So in the case of number 1, the slope is -2. For number 2, the slope is -3/2. For number 3, the slope is 7/3. Okay, and then 4, 5, and 6 get a little bit more tricky because take a look at number 4. There is no x value. So we need to ask ourselves, we can approach this a couple different ways. We can say, well, what would make the x disappear from this equation? In other words, we have basically y equals, we're missing the x value, -5. Well, if it was just y equals -5, what would the value of the slope have to be in order to make the x disappear? And that would be 0, because 0 times x is 0, and 0 minus 5 is -5. So our slope is actually 0. Okay. The other way we can look at this is, okay, let me get a, if I'm more of a visual person, let me graph this. If y equals -5, that means for any x value, y is -5. So if x is 1, y is -5. If x is 2, y is -5. If x is 3, y is -5. If x is -2, y is -5. And I see very quickly here that what I have is a horizontal line. And maybe I remember from our notes and from our practice that horizontal lines have 0 slope. So the answer to number 4 is 0. The answer to number 5, we have the x value, but there's no number there. Hopefully you'll remember that the coefficient of x when there is no number there is 1. So our slope is 1. Now for number 6, we do have an x term, but we have x equals 5. This is not in y equals mx plus b form, and we don't even have a y. So this might be helpful to graph this equation, and I'm going to switch to a different color here. If x is 5, that means y could be anything. So let's see, 1, 2, 3, 4, 5. So there's 5. 5, 1, 5, 2, 5, 3, 5, -1, 5, -2, 5, -3. We see quickly that what we have here is a vertical line, and hopefully we remember that vertical lines have an undefined slope. Okay, now if you can't remember about the horizontal and vertical, remember there was a shortcut thing that we wrote in our notes, HOI VUX. Horizontal, 0 slope, y equals. Vertical, undefined slope, x equals. If you remember HOI VUX, you'll remember which slope goes with which type of line. Okay, that is section 1. Let's move on to section 2. I can find the slope of a line given 2 points on the line. So when you're given 2 points, you have to use the slope formula. The slope formula is y2 minus y1 over x2 minus x1. And this is just simple subtraction and division, but we have to be careful about negative values, okay? So our slope here's y2 and y1, so 18 minus 4, x2 and x1, 14 minus 8. It's also important that you do the second one minus the first one, because 18 minus 4 is not the same thing as 4 minus 18, so you got to be careful. 18 minus 4 is 14, 14 minus 8 is 6. We can simplify. If we divide by 2, we would get 7/3. There's our slope for that one. Now here, number 8 is where we have to be careful with all these negatives. So y2 is -1 minus y1, which is -9. You end up with double negatives there. All right, the subtraction sign in the formula is not the same as the negative sign in the number. They're separate, so you have to write them separately. -3 is x2 minus, and then -1. So remember that when you have double negatives, it really turns into a positive. So I like to rewrite this. If you can do it mentally, that's perfectly fine. And we have 8 divided by -2, which is -4. All right, be extra careful with those negatives. Let's take a look at number 9. y2 and y1, 14 minus 9. x2 and x1, -6 minus -17. 14 minus 9 is 5. My 7 just wouldn't, there we go. This is -6 plus 17, which is 11, and 5/11ths cannot be simplified. So there you go. Number 10, y2 minus y1, 14 minus 3. x2 minus x1, -16 minus -16. That gives us 11 over -16 plus 16, 11 over 0. And you know you cannot divide by 0. If you go into Desmos or any calculator and do 11 divided by 0, it's going to tell you error, which means the slope for this one is undefined. This represents a vertical line. For number 11, y2 minus y1, -11 minus 14. x2 minus x1, 18 minus 4. This gives us -25 over 14. And let me think, I don't think there's anything that we can simplify. Nothing will go into both of those numbers, so that is our answer. And for number 12, here's y2 and y1, 13 minus -14, -7 and -6, -7 minus 6. This turns into a plus. This is going to be -13. This is going to be 27 over -13. Now, we cannot simplify this. -13 is prime, but remember what I told you guys about the proper way to write a negative fraction is to put it either the negative sign in front of the whole fraction bar, like this, or move it up to the numerator. All right, either one of those would be correct. This is not mathematically wrong. It's just not proper. It's like writing your name with a lowercase letter. It's just not proper. The proper way to do it is with a capital letter. The proper way to write a negative fraction is with the fraction symbol out front or in the numerator. Okay, so there was finding the slope given 2 points. Now, we also had to be able to find the slope given the graph of a line. And let me see if I can enlarge this some so that I can write on it a little bit easier. So remember that when you have a graph and you need to count slope, you are looking at rise over run. So it needs to be up and over. If you go up and over to the right, that's a positive slope. If you go up and over to the left, that's a negative slope, okay? So this way is positive, this way is negative. So looking at number 13, I can see that I'm going to have a negative slope. You start at the bottom point and you count how many spaces you go up to the level of the top point. So 1, 2, 3, 4. 1, 2. So 4 over 2 is 2, but this is a negative slope, so negative 2 is your slope. All right. You can also think about a number line. If you go to the right, it's positive. If you go to the left, it's negative. So I went up and left. So really the 2 would be a negative 2, and that's how I get my final negative answer, okay? Let's look over here at number 14. If you remember that a horizontal line has 0 slope, you can just write 0. But if you don't remember that, we can do rise over run. To get from either dot to the other dot, I don't go up any. But I would need to go over 1, either that way or that way. And it doesn't matter if you say 0 over 1 or 0 over negative 1. Both times your answer is going to be 0. All right, so even if you don't remember that a horizontal line has a 0 slope, you can still calculate it. Going to number 15. Let's say, ooh, here's a vertical line, but I never can remember if the vertical line is 0 or undefined. Well, let's just figure it out. So if I start at the bottom line, I'm going to go up 2, but over 0. 2 divided by 0, not possible. You can either remember that, or if you're not sure, put it in Desmos. Let Desmos tell you. And for number 16, starting at the bottom, our rise is 1, 2, 3. Our run is 1, 2, 3. And I'm going left, so that's negative. Our slope for this line is negative 1. Another hint that you can use for this one is when you see that the line goes through at a perfect 45-degree angle like this, see how it crosses at every intersection? That is a slope of 1. So if you're going to the left like this one, it's negative 1. If your line went in a perfect stair step like this to the right, that's a slope of positive 1, because you're always going up 1 over 1, up 1 over 1, up 1 over 1. So just a little hint to help you remember. It looks like we had a couple more here, so let me enlarge this again. All right, for number 17, rise over run. We're starting at the bottom. We're going 1, 2, 3, 4, 5, 6, 7, and over 2. 7 over 2 can't be simplified. That is our slope. And then finally number 18. Starting at the bottom point, 1, 2, 3. 1, 2, 3, 4, 5. There we go, 3/5. All right, I hope you remembered slope. If you have any questions, please feel free to email me about those. And let's talk about now reversing the process and actually drawing. We're going to graph the linear equation in 2 variables. Given the equation in slope-intercept form, we're going to draw the graph. So let's zoom in on number 19. So we know from looking at our equation that our slope is negative 2/3 because that is the coefficient of our x value. And remember that in y equals mx plus b, b is your y-intercept. This is where your line crosses the y-axis. I need to start with this because I can't count up and over, rise over run, if I don't have a point to start with. So I know that my y-intercept is -3, so I'm looking at my y-axis. I go down to -3 and I put a point. Now I know that I'm going to be going up 2 and over 3, and since it's negative, I'm going to be going left. So from this point, up 2 over 3. There's my second point. And then once I have 2 points, I'm able to, there we go, I don't have the capability of making a straight line here. I'm able to draw my line. Okay. Let's look at number 20. The y-intercept is -2, so go down to -2 and put a point. Our slope is 3/4 and it's positive, so I'm going to go up 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Put a point here and do my best to make a straight line. Hopefully you have a ruler, but if not, that's okay. Number 21, my y-intercept is -2, so I'm going to put a point at -2. Now I have a whole number slope. My slope is 2, but I need rise over run. So how could I write 2 as a fraction? 2 over 1. So up 2 over 1, and there we go. Since it's a positive number, I went to the right and do my best to make a straight line. And for number 22, my y-intercept is -5. My slope is 4/5, so rise 4 and run 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's my second point, and make my straight line. For number 23, okay, y equals x. So let's look at this. If I want y equals mx plus b, m would be the coefficient of x, which would be a -1. So y equals -1x. That means I have my slope. What I'm missing is my y-intercept. Well, if it's missing, that means it was 0. Because we wouldn't write -1x plus 0, we would simplify this to -1x. And then we would simplify it further to just -x. So we can backtrack and figure out that this is what the full equation is. So the y-intercept is 0, and a slope of -1 means up 1 and left 1. So up 1, left 1, up 1, left 1, up 1, left 1. It's a little bit easier to do it as a stair step. All right. And here is our line. And then moving to number 24, we have a y-intercept of +3, and our slope is 1/3, so up 1 over 3. All right, up 1 over 3. And our line looks like this. Okay. So there you are, drawing your graph from your equation in slope-intercept form. It's pretty straightforward. What makes it a little bit more complicated is if you get to a page like this, where they are giving you the equation in standard form. You must, as I said earlier, you must convert the equation to slope-intercept form, because you can't just can't just look at this and say, oh, it says 2x, so the slope is 2, because x is on the same side as y. If I say 2x plus y equals -2, if I solve this for y, I need to subtract 2x on both sides. Here is the equation in slope-intercept form, and look, the slope is not 2, it's -2. Moving the x term to the other side of the equation will make the opposite number. So instead of 2, it would be -2. So you have to be really, really careful that you change your standard form into slope-intercept form before you attempt to graph it. Once you have that, then our y-intercept is -2. Our slope is -2, which would be -2 over 1. So that's up 2 and left 1. And our line looks something like this. Okay. Moving to number 26, if I have x minus y equals 1, I have to solve for y. So I'm going to subtract x, negative y equals negative x plus 1. Well, I don't want negative y, I want positive y. So basically positive y is the opposite of negative y, so I need the opposite of everything over here. So that would be positive x minus 1. You just switch the signs of everything. So our coefficient of x is 1. Our y-intercept is negative 1. If we have a slope of positive 1, that means up 1 over 1, up 1 over 1, up 1 over 1. It's a perfect 45-degree angle. There is your line. Okay. Going to number 27. I see that I have standard form. I need to change. So 2x plus 5y equals 10. Subtract 2x on both sides. And actually, I'm going to move this over some. 5y equals negative 2x plus 10. And then I have to divide by 5. So what I'm going to do is divide everything by 5. These 5s cancel out. The x term does not, so negative 2/5 has to stay negative 2/5, but 10 divided by 5 is 2. So that turns out to be my y-intercept. My slope is negative 2/5, so I'm going to go up 2 and to the left 5. 1, 2, 1, 2, 3, 4, 5. And that's going to be my line. Moving on to number 28, I have x minus 2y equals 4. Subtract x, negative 2y equals negative x plus 4. Divide everything by negative 2. So y equals, remember that this is a 1, so negative 1 divided by negative 2 is really positive 1/2. And 4 divided by negative 2 is negative 2. So our y-intercept is negative 2. Our slope is 1/2, up 1 over 2, up 1 over 2, up 1 over 2, and there's our line. A couple more. We're looking at number 29 here. I've got x plus 3y equals negative 6. I'm going to subtract x on both sides. So 3y equals negative x minus 6. Divide everything by 3. Y equals, this is a negative 1, so we have negative 1/3 x. And negative 6 divided by 3 is negative 2. So y-intercept of negative 2. I feel like we've had a lot of those. And negative 1/3 means up 1 and to the left 3. So 1, 1, 2, 3. 1, 1, 2, 3. And your line looks sort of like that. And then we're here at number 30, which I think might be the last one. 4x minus y equals 4. Subtract 4x. Negative y equals negative 4x plus 4. Since I have a negative y, I need positive y, so I'm going to change all of the signs to the opposite. Basically, in case anybody's not sure why we're doing that, let me show you. This is negative 1y. I need to divide everything by negative 1. Negative 4 divided by negative 1 becomes positive 4, and positive 4 divided by negative 1 becomes negative 4. So it has the same effect. Dividing by negative 1 just has the same effect of changing all the signs. Our y-intercept is negative 4. Our slope is 4, which is 4 over 1. So up 4 over 1. Up 4 over 1. And we have a pretty steep, oh, that was definitely not really well angled, but there you go, pretty steep line. And that, my friends, is not the end. But wait, there's more. Okay, but that's this section. Be very, very careful of standard form. I do remember seeing a couple of you guys not changing to slope-intercept form before you attempted to graph or identify slope. You have to have it in slope-intercept form. So let's go to target 4. This is the last page, I think. Yeah, okay, so target 4 says to write an equation for each function, description, and then graph. So we have words here. Whoops, I forgot to take that off. Okay, so let me zoom in. So we need to first make an equation out of the words. So y is 3 more than, remember that means plus 3. The product means multiply 2 and x. So there you go. Y is 3 more than the product of 2 and a number x. Now that we have this, we can say, all right, our y-intercept is 3. My slope is 2, which is really 2 over 1. So up 2 over 1, up 2 over 1, and here's my line. I really wish I had a ruler function on this page because those squiggly lines are bothering me. All right, let's go to number 32. Y is, that's y equals 1 less than, so minus 1 at the end, a number x. So y is 1 less than a number x. Y equals x minus 1. Our y-intercept is negative 1, and our slope is 1x. So we're going to go in a perfect diagonal to the right because it's positive. And this is our line. Let's go to 30. Oh, that's it. Only the 2 of those? Oh, why did I think there were more? All right. So there you go for that. Here we go, transformations. So transformations of the parent function y equals x. Y equals x is called the parent function because it is the equation, it is the graph, rather, of the perfect 45-degree diagonal line. Okay, it is the simplest. It's called the parent function because it's the simplest possible linear equation. You have a 0 y-intercept and a slope of 1. So it's the simplest form of the equation. We can do a couple different things with this line. I can keep the slope and I can just move it up or down. That is called a translation. I can keep that equation. Ooh, can I not change? Oh, I can change colors. There we go. Now let's make it purple. I can keep the y-intercept and I can change the steepness of the line. Okay, that is a rotation. Okay. Or, and let me do one more color here. Let's do turquoise. Or I can take this line and I can do the exact opposite slope going the other way. That is a reflection. So those are the 3 possible transformations that we have, okay? So let's go up to our questions here. Question 33, a line has the equation y equals 3x plus 1. Which element of the equation should be altered to make the line less steep? Well, steepness is slope. So if we want to make the line less steep, we should alter the 3. All right, instead of keeping the 3, we should make the slope something else. Now, if we want to make it less steep, we need a number that is smaller than 3. So any equation where the slope is smaller than 3 would be fine. 2x plus 1, x plus 1. You could make it a 1/2 x plus 1. Okay. Number 34, which transformation is achieved by altering the y-intercept? So we just talked about if you're altering the y-intercept, you're sliding, look at the red lines, you're sliding your line up or down, and that is a translation. Which transformation is achieved by altering the slope? That's a rotation. Which transformation is achieved by replacing the slope with its opposite number? So for example, if you had y equals 2x plus 1 and you made y equals negative 2x plus 1, that is the reflection. Write any linear equation in y equals mx plus b form. All right, I'll write y equals 5x plus 2. Now, write the equation that would be the reflection of that line, just make the slope negative. There you go. And that covers all of Unit 3. I hope this was helpful to you in jogging your memory and remembering all of this fun stuff about slope. Please feel free to email with any questions that you had if there's anything that you are trying to figure out and you just can't get. All right, I'll see you guys next time.